Rotational motion refers to when an object spins around a fixed axis. In biotechnology, microcentrifuge uses this concept. Samples are loaded into the microcentrifuge and rotate at a very high speed around a central axis. The rotational motion creates a strong outward force on the sample. As a result, denser components known as pellet move outward and settles at the bottom of microcentrifuge tube, whereas lighter components known as supernatant remain at the top. This separation method is applied in various tests and experiments such as blood analysis and DNA extraction.
Explain rotational motion in computer graphics. I'm Rosmati from the MCG program. Okay, it's built on this core equation, angular kinematics, delta equals omega t plus alpha t squared, covering displacement, velocity, and acceleration. Okay, in 2D, this principle animated wheels, gears, and the sprite in the classic video games. For 3D, we use quaternions to avoid gimbal lock and enable complex animation. This is implemented in the engines like Unity and Unreal. For us in MCG, this is the key to animation, software, game development, CAD, simulation, and advanced 3D visualization. In conclusion, rotational motion is the fundamental link that turns abstract physics into visual, believable digital reality.
Torque is a force that causes an object to rotate around an axis. In daily life, torque happens whenever we turn or twist something. In a laboratory setting, torque is commonly used when adjusting a microscope. For example, when we turn the focus knob or the lamp intensity knob, we apply a force that causes the knob to rotate. This rotation is an example of torque in action. The amount of torque depends on how much force we apply and how far the force is applied from the center of rotation. Without torque, we would not be able to precisely adjust the focus or brightness of the microscope, which is very important in biotechnology experiments that require accurate observation.
Hey everyone, my name is Anik Azhar. So today I'm going to explain about the rotational dynamic in PHYSIC engine. So over here is the understanding torque and rotation. You can read over here. Next, we move into the torque engine in PHYSIC engine, which torque is the rotational force that causes an object to rotate about an axis. It controls angular acceleration and rotational speed, determines the direction and stability of rotation, and used to simulate spinning wheels and rotating rigid bodies, essential for realistic animation, simulation, and games. So over here is the equation of torque. So now, in conclusion, torque is a fundamental concept in rotational dynamics that governs object rotation in PHYSIC engine. Its application ensure realistic rotational behavior, enhance the accuracy and visual quality of animation and simulation in computer graphics.
Next, I will explain solid and fluid and their application in biotechnology and MCG. Solid and fluid are studied to understand how materials behave and flow in real-world systems. Solid have a fixed shape and volume, while fluid can flow and take the shape of their container. In biotechnology, these concepts are applied in tools such as micropipette, bioreactor, and centrifugation. In MCG, they are used to study fluid-solid interaction and fluid simulation. In micropipette, pressing the plunger increases pressure, pushing liquid out. Releasing it lowers pressure, drawing liquid in. Force on a small area creates pressure, which is transmitted equally through the fluid, demonstrating Pascal principle. Solid and fluid are essential in biotechnology and MCG. Key properties such as pressure, density, and viscosity, and principles like Pascal principle, Archimedes principle, Bernoulli principle, and surface tension help us measure, control, and simulate complex systems.